Thank you very much. So I'm going to ask you to follow along with me on your laptops. So please, if you have R in RStudio installed, please open your laptop. Now, I'm going to be going slowly to begin with and then get quite fast. So I'm going to expect people to fall off during the live coding. That's fine. At the very end, I'm going to be doing things so quickly, I don't think anybody will be able to follow along. That's fine. That's expected. I'm just going to try and make sure you can do some things at the beginning. OK, so I've provided a link to you. So that's on the screen and in the Zoom chat. And that will take you to this web page, which has some code I'm going to make you run in a little bit. Yes, OK, so also forgive me, this is the first time I've presented in public since the pandemic, and there's been lots of changes for me since the pandemic started. So yeah, OK, so my title is too long. So what I'm going to do is I'm going to talk about two things. I'm going to talk about R, what it is, and the R user community. I'm going to talk about static data visualization with Gplot2. I'm going to talk about interactive data viz with R. And finally, I'm going to talk about reproducible research and data visualization with R. So those are the things I'm going to talk about. So R, could you put up your hand if you've never used R before? Awesome, lovely. OK. So what do you get when you install R? So I asked you folks to all install R, and there are three things that you get. The first is the gubbins necessary to run R code. So your machine now can run R code, which is awesome. The second thing that you get is a bunch of packages, which collectively we call base R. So this means when you install R, you can do a bunch of things out of the box because of base R. There's lots of packages in base R, and we'll see them. What's really nice about base R is everyone has them. So if you see somebody mention base R, you go, oh, I've got that. Everybody else has got that as well. You also get an application for running R code, which in macOS is called R, and in Windows is called R GUI. And, OK, so that doesn't like me. So you get this application called the R console, and it's rubbish, and it's not where we write R code. Unfortunately, it is a place that lots of people do write R code, but it's just not great. So where should we be writing code? We should be writing code in RStudio, which is an application I made you install. And the reason that I did that is because RStudio is an IDE designed for R code. IDEs are what real software developers use, and you're all real software developers. The moment you write one function in R, you're now all software developers and data scientists. So that means that you should use an integrated development environment, which is the application that real software engineers use to write R code. But RStudio is also awesome for us who want to do research. It's got lots of tools built into it for doing data visualization, including interactive data visualization and Shiny apps. So we're going to go over to RStudio. So I have RStudio here. On the left-hand side of the screen, so if I draw my floating box, this part of RStudio is the exact same thing as the R console or the R GUI on Windows. And in here, you can type code, like 2 plus 2, you hit enter, and you get output. So we can see 2 plus 2 is 4. That's great. We're now all software developers because we've written some code. Now, what I'm going to do is I'm going to get you to use RStudio projects, and I'm going to do that because RStudio projects improve reproducibility. So I want you to go to the top right-hand corner of RStudio, click up here, and I want you to select New Project. It's just going to tick over. And then we're going to choose New Directory. We've got lots of options here, but we're going to go for New Project. And I'm going to make a project on my desktop. And I'm going to call it Today's Date, 2022-07-13. OK. And then we're going to create our project. So we now have a project, and we've still got this console thing here, which is where we can write code. So we can write slightly more complicated code, 2 times 4. But the console is a piece of scrap paper. We write code there, it's run, and it's thrown away. If we want to record code into the future, we want to write it into script files so we can save those files and we can rerun our code in the future. So to create a script file, we go to File, New File, and we select our script up here. That now gives us a script file. And we can write code in here. So I can write 2 times 8. And if I want to run that code, you select the code that you want to run. And in Windows, you press Control-Enter. And macOS, you press Command-Enter. And what happens is your selection goes to the console, it's run, and you get your output. So this thing here is called a prompt. And this tells you that R is awaiting new input. What you are going to do tens of thousands of times is you're going to misselect code in RStudio. So I'm going to deliberately misselect code now. So I'm going to try to select 2 times 8, but I'm going to miss off the 8. I press Command-Enter, Control-Enter in Windows. I don't get back what I want, so I reselect it, I press the keyboard shortcut, and I get back something completely unexpected. And that's because we misselected our code. So if we look at that short loop again, so I select my code, and the console does not show the right angle bracket, which means that RStudio is expecting new additional input. So if you've misselected code, put your cursor in the console and press Escape. Every time you want to run code for a new time, you're looking for this thing in the console. If you don't get that thing, put your cursor inside there and press Escape. Okay? Awesome. Right, so I should probably introduce you to functions. So my favorite function in R is called rep, and it takes 2 arguments. The first argument is a thing, and the second argument is the number of times that you want to repeat that thing. So if I want to say hello world 5 times, I would use the function rep, hello world, comma, 5. And I get back hello world 5 times. Okay. So CRAN is where R lives. So when you went and downloaded R, you got it from CRAN, and all historic versions of R are available there, and it's also the package repository for R. So it contains over 18,000 packages, and they were all installed in the same way. You use the function install.packages. What I would like you to do now is to go to the URL that I provided to you, and I want you to select lines 4 through 6, copy those to your clipboard, go back over to RStudio, paste them into your console, and hit Enter. And that's now going to install the packages that I want you to use today, and hopefully you might choose to use them in the hacking activities as well. So if you hit Enter, that's going to go and start installing the packages. So the Tidyverse is an awesome part of the R community. The Tidyverse is a collection of packages for doing data science. It combines several tools together that allow you to do data cleaning, wrangling, modeling, and data visualization. And the Tidyverse is the backbone of the R for Data Science book. The R for Data Science book is the book that you can read online for free, so it's available here, and you can also buy a physical copy of it as well. If you're interested in learning R, either shoring up your skills, or if you've never used it before, this is the protocol that I would recommend for you. It's awesome. As well as the book itself, there is also the R for Data Science online learning community. So this is a service where you join a Slack group, and you can go through the exercises in the R for Data Science book together and get help from folks who've used R for years. So the R for Data Science book is really awesome, and the community supports you in learning how to use R, and the Tidyverse is the backbone of that book. And we're going to be using it in this little session now. So I want to also talk about the R community, and the R community is really awesome, and the R community lives on Twitter. RStats is the hashtag for R, and I have genuinely learned between 60 and 70% of the R that I know from Twitter. So I've searched for RStats, and I can see the most recent tweet is from Garrick, and what Garrick has done here is he's taken profile images submitted to RStudio Conf, and it's identified faces in the images, and then it's cropped nice circles around the faces in those images. So this is a link to a blog post about how to do this in R, and if we scroll down, there are lots of awesome things being done in R. So you can see this is a package I've not used before, MapIso for making relief maps, and there's lots of different things. The R Stats community on Twitter is an awesome place to learn R and to feel part of the community. Oops. The R community does also a lot of work to try and elevate voices that you don't typically hear from in programming communities, and that's managed by R Forwards. So R Forwards tries to increase diversity in all directions. Probably the most prolific direction in which diversity is increased is R Ladies. So R Ladies seeks to be a community for non-men to come together to learn R together and to have a space to come and learn R. R Ladies is awesome, and they have chapters throughout the UK and around the world. R Ladies is a really awesome organisation. Okay, and okay, back to here. At the bottom of my slide, oh, yes. So at the bottom of my slide, there's a link to a book which is about Twitter and using R for Twitter as well. Okay, so some data visualizations, please, instead of Twitter. Okay, so let me get to the Gplot2 chapter. So I want to talk about data visualization with Gplot2, but in order to do that, I need some data sets. So let's go over to RStudio. And now our packages are installed. I'd like you to go to the top of the script file, create a couple of new lines, and what we're going to do is we're going to load two packages. We're going to load the Tidyverse package by running library Tidyverse. So I typed this code, and then I press Control-Enter in Windows, Command-Enter in macOS. That runs library Tidyverse, and it loads that package. And the Tidyverse package is special, and it loads several other packages as well. So we've now got Gplot2 and a bunch of other packages as well. The other package that I want you to load is the 538 package. The 538 package is a package which contains lots of data sets from the 538 data journalism site. So 538 do lots of really good data journalism, and back in 2014, there was an article written, The $0.01 Case Against Hollywood's Exclusion of Women, and this was looking at how production companies in Hollywood deselect movies which contain strong female characters. And so what the author of this study wanted to do is they wanted to show that movies that contain women with agency make money, to make a case for producers. Obviously, movies should contain women anyway. But what the article was able to show was that movies that contain women with agency do make more money than those without. And it made use of something called a Bechdel Test. The Bechdel Test is a very minimal test for whether a movie contains women with agency. Are there two characters who are women? Do they contain names? Do they talk together? And do they talk about something other than a man, or something other than furthers the storyline of a man? So that's the Bechdel Test. And what's really lovely about 538 is all of our analysis is done in R. So the 538 package contains this data set. So if we go back over to RStudio, and I'm going to type Bechdel, and if we hit Control-Enter or Command-Enter in macOS, what we get printed to the console is this data set. So we've got 1,794 movies in here. We've got the year they were published, their IMDb ID, their title, and then we've got 3 test columns. Test, which comes from BechdelTest.com, clean test, which cleans this up a little bit, and then simply the binary, does the movie pass or fail the test? So what I want to do with this data set is I want to count how many movies passed the test and how many movies didn't. So I'm going to use the function count. So the function count is from the Tidyverse, and it tells me 991 movies failed the test and 803 movies passed the test. That's pretty cool. One of the really nice things about RStudio is if you want to see the documentation for something, you select the thing you want documentation for. So I want to see how count works. So I select it and I press F1 on my keyboard, and that shows us the documentation for that function. Now the thing about the Tidyverse is it contains this thing. This thing here is called a pipe. So the way that we would more traditionally write this code using the Tidyverse is to pipe it into the function count. So this code is exactly the same as this code. What a pipe does is it grabs the left-hand side of itself and it forces it into the first argument of the right-hand side of itself. So it's a little bit complicated to understand with count, and this is why rep, this very boring function, is my favorite thing in R. So if I type hello world, and I type a pipe, and I type rep 5, and I run this code, so I select it, I press Command-Enter in macOS, Control-Enter in Windows, I get the same output as I would get if I run this code. So what a pipe does is it rewrites code for us. This is the thing that's magic. It's not rep or count that's magic. It's the pipe that's doing the thing. And the pipe is from the Tidyverse. Okay. So at the moment, I've just counted by binary, but maybe what I wanted to do was I wanted to count how many movies passed and failed a test in each year. So I can see in 1970, there was only one movie, and it passed the test. And in 1973, 4 failed and 1 passed. Okay? So that tells me a little bit about the movies that passed the test. Now let's say that I'm interested in the profitability of the movies. So I want to visualize this with a scatter plot using Gplot2. So I'm going to take Bechdel. I'm going to pipe it into the function ggplot. And what I get back is this very distinctive, very attractive grey rectangle. And this grey rectangle is a Gplot2 chart, which is awaiting some more information. So Gplot2 is called Gplot2 because it provides a grammar of graphics in R. And we can use Gplot2 to build almost any static data visualization that we want in R. It's a really awesome package. But the thing about Gplot2 is that we build charts instead of choose charts. In Excel, when we want to make a chart, we go to charts, we say, okay, I want to make a line chart, and I select the data. With Gplot2, we need to ensure that our data set itself contains all of the information to build a chart, and that's because of the grammar of graphics. So there are 5 different components to a Gplot2 chart in order to build a chart. The first and most important part of a chart is the aesthetics. The aesthetics are the mappings between the columns in our data set and the coordinate systems in our chart. So if I go back to my very boring grey rectangle here, I want to add a coordinate system, 2 coordinate systems, in fact, an x-axis and a y-axis. And I do that in the function AES, which stands for aesthetics. So I'm going to say that x is going to be equal to budget in 2013 dollars, and y is going to be equal to domestic gross 2013. And now when I run this code, our grey rectangle has more information. It's used those 2 columns to create coordinate systems. It's created 2 continuous scales because those columns contain numeric data. So the type of scale that you get depends on what type of data you have in your column. So that's the first part of Gplot2. We create mappings between a data set and coordinate systems in a chart. And the second part is using geomes. So geomes add layers to our chart using our aesthetics. So in Gplot2, we use the plus operator, which means plus, to add additional layers to our chart. So this is a scatter plot. I want to add points to the chart. So I use geome point, and now we get points in our chart as well. So geomes make use of the aesthetics to add layers to our chart. Now I might want to add additional aesthetics. So inside of geome point, I could say AES color is going to be equal to binary. So now we've added an additional scale. So because our scale is a discrete variable, we now get a discrete scale, discrete legends. So we've got movies that either fail or pass the test. So this is a process that we go through for building our charts. Now, if I wanted to customize the colors in there, then I would use a scale function. So I could say, okay, I'd quite like to use Viridis. Viridis is a really great color palette. So there's 3 different versions of Viridis. So let's go for discrete. And that didn't work. Okay. B. Oh, that's because I said fill instead of color. So I want to do D and color. Oh, and please forgive me. I've been recording courses for LinkedIn who are based in America. So I've been doing this for the last 3 weeks instead of color with a U. Gplot2 and the whole of the Tidyverse was built by Hadley Wickham, who's from New Zealand. And that's great, because it means we get American English and British English in Gplot2. So yes, so that's why the U has been dropped. Yeah. So we get geomes. And then if we want to control how geomes appear in our chart, so we would use factors. So I have 2 different bar charts here. One ordered alphabetically, which is how Gplot2 works by default, and another where we're using factors. So factors is how we control the order of things in our charts. So we've got aesthetics, geomes, and scales, and I just used the scale color to change the scale. So instead of the red and blue, it's now using colors from the Viridis palette. We then have guides. So this thing here is the legend. That's a guide. So if we wanted to change how this looked, we'd go into guides. And then finally, if we wanted to change the look and feel of the chart, then we would use themes. So let's say I want to make this chart printable in black and white. I'm going to use theme BW. And that's going to get rid of that grey background. And now we've got a chart that's easier to print. Okay. So that's the very basics of building Gplot2. But I really don't expect you to be able to go and build a Gplot2 now without any errors at all. Just trying to explain those things. In the link that I provided to you, there is a link to my slides, so you have all of my slides. So, why is Gplot2 awesome? Gplot2 is really awesome because of the consistent grammar of graphics. We can use it to build any kind of chart that we want. It's awesome. We also can use it to build maps. So Gplot2 now has support for maps using the SF package. So these lines of code, 1, 2, 3, 4, 5. These 5 lines of code are making us a continuous scale choropleth. So this is really awesome about Gplot2, that we can do this. We can also create animated GIF with ggAnimate. Now you might go, what's the point in an animated GIF? Animated GIF are really great for telling stories, and they work really well in social media as well. So this is a data visualization, I think from 2017, which shows how our planet is warming over the last 100 years. And because it's animated, it tells that story really nicely. And ggAnimate allows us to animate any kind of Gplot2 chart, which is really awesome. And the reason that we can do this is because of Gplot2 extensions. So Gplot2 extensions are packages that provide additional things to you. There are more than 113 extensions available at this website. So there's lots of different things. There's statistical ones, there's patchwork, and one which came out recently that I absolutely adore is Geome TextPath. So Geome TextPath is really nice. It allows you to draw text on a line. So that doesn't look that useful. That looks a little bit more useful. And then if we get down here, that's really quite beautiful. But because Gplot2 is so consistent and built together, we can use Geome TextPath with SF objects in our maps. So if we have a map with rivers, we can add a really lovely label to that river because Gplot2 is so consistent and all built together. That's why it's awesome, and I can't recommend it enough as a tool for building static data visualizations or animated GIF. So, interactive things now instead of static things. So, as you're going to hear from Dr. Alfie Abdul-Rahman later, the interactive web is built with JavaScript. So, if you're looking at an interactive map, interactive chart, you're looking at something built with JavaScript. And just like R, in JavaScript there are packages or frameworks that are designed for building data visualizations. And in R, there's a tool called HTML Widgets. And that's a package for R developers that allows an R developer to build an R package that wraps a JavaScript package. So what that means is we, as people who just want to make data visualizations, now have a package that allows us to make interactive things by only writing R code. That's really awesome. We don't have to learn JavaScript to build some things. Now, if you want to build very customized things, so I want to show you day in the life flowing. So I want to show you my favorite data visualization in the world. And it's not this one. This one's useless. Useless. What does that mean? Nothing at all. This is my favorite data visualization. And so this is an interactive data visualization, and it shows you how Americans move between different states through the day. It's a really awesome data visualization, and this was built with D3. To build something like this, you need JavaScript. You need to write it custom. But if you want to build some things, you can use HTML widgets. So my favorite data visualization in the world, and something you can build with D3, and lots of data visualization experience. Let me show you what you can do with HTML widgets. So on the HTML widgets website, there is in a showcase 13 packages which are very good, very popular, that allow you to do different things. So there's Leaflet, which allows you to make interactive maps. There's Plotly, which allows you to make interactive charts. And there's Viz Network, which I really enjoy, for making interactive network diagrams. And you can make actually useful ones. Dragging things around like this isn't really useful, but you can use this interactivity to build networks which collapse and do other exciting things as well. And then when we're talking about data visualizations, we should also talk about tables. With interactivity, tables become really dynamic and a really interesting way to explore data. So the DT package allows us to create interactive tables. So we can do things like sort by column, we can search within a table, and with these packages, we can also include spark lines. So inside of our table, we can have little bar charts, little line charts, and things like that. So with interactivity, tables become really interesting again. Okay, so only getting slightly carried away with how much I love HTML widgets. So I do need to give you a sanity check with HTML widgets. Each HTML widget is completely different to the next. And the reason for that is each HTML widget wraps a different JavaScript package. And each JavaScript package is different. So Plotly is completely different to Leaflet, which is completely different to Viz Network, which is completely different to X. So that's one reason why they're different. And they're also different because they're written by different R developers. And the R developers can make choices about how they build the HTML widget. So they might want to make the HTML widget as close as possible to the JavaScript. So my favorite HTML widget is Highcharter, and it's as close as possible to the JavaScript API, and that's really nice because I can read the JavaScript code and translate it over into R code really easily. But there are other packages which go, I'm designed for R people. I want to make this package as close as possible to how R works, not to the JavaScript package. Okay, so can I get your hands for who is interested in making maps? Maps, little interest. Charts, more interest. Okay, how about we make some charts very quickly? Okay, so what I'm going to do is I'm going to load the Plotly package. And what I'm going to do is I'm going to grab my data visualization code. So I'm going to copy lines 19 through 24, paste it here. I'm going to store this as an object called ggBechdel. I'm going to run this code. Oops, there we go, run that code. And now I'm going to take ggBechdel and I'm going to pipe it into this function ggplotly. And what ggplotly does is it attempts to turn a static Ggplot2 chart into an interactive chart. And it does an okay job at it. Some people tell you this is the best thing on earth. I hate it. Now, I hate it because I don't like knowing I can only get so far and then there's a huge cliff that I fall off. So Ggplotly can create interactive charts from simple Ggplot2 charts. But if we want to create real customizability with Plotly, we would build our chart with Plotly. So I take Bechdel, I pipe it into plot_ly. I would set the x-axis as tilde, budget 2013, y is equal to tilde, dom gross 2013. And then I think I do trace scatter. Marker. So that's enough code to build this. So now I've got an interactive scatter plot. So if I hover over those, it's showing me the values of each of those. I could go in and I think I'd do if I do text, title. So if I add the text argument to Plotly, now we've added the title to our movies, and we could go on and add additional interactivity into this. Plotly is really awesome. I don't like Plotly because Plotly doesn't have very good accessibility tools. So Plotly is free to use, however, it is not good for accessibility. My favorite HTML widget is called HighCharter, and it allows you to make these really beautiful data visualizations. The thing about HighCharter is it depends on the HighCharts JavaScript library, and that's not free to use if you're in government or industry. So it's free for education and charities, but it's not free otherwise. And I really love HighCharter because it uses HighCharts, and they're really beautiful, very glossy. They're very good from an accessibility point of view, and they also work really well on both desktop and touchscreens. So I really love them for that. Okay, so that's HTML widgets. So HTML widgets allow us to build these individual interactive things, interactive maps, interactive charts. I only showed scatter plots. We can do all sorts of things, box whisker charts, violin charts. So then we come to Shiny. So Shiny is a tool which allows us to build web applications with the R language and only with the R language. So back when I used to work at University of Oxford, I started up this thing called the Interactive Data Network, and the Interactive Data Network was this service for academics at Oxford to build interactive data visualizations of open access datasets. And what we wanted was we wanted a tool that was easy for researchers to learn. So R is pretty easy to learn. Some of you have followed along and made a Ggplot2 chart and an interactive thing, so that must be pretty easy to learn. And then what we wanted is we wanted a web app to connect to the canonical dataset. And the canonical dataset is the dataset with a DOI. If your dataset doesn't have a DOI, it's not a dataset, it's just something which is going to disappear. You need your dataset to have a DOI. So we wanted the web app not to contain a version of the data, but instead to connect over to the repository. So to connect to Figshare, Zenodo, an institutional repository, and download it. That was really important to us, so that if researchers improved their data in the future, or they needed to correct it, then the data visualization was always correct. And Shiny was the only tool that allowed us to do that at an affordable price. So if we go to idn.it.ox.ac.uk, then this is the website, and I left before it really got off the ground, and it's still kind of on the ground a little bit. So what's going to load down here is a Shiny app that I built for the Online Labour Index project. So I'll get my floating rectangle, which I like a little bit too much. So this portion of the web page is an iframe. So contained within here is a Shiny app which is slowly loading, and that Shiny app connects to a Figshare deposit and loads the data in. And the internet connection here is really, really not good, so that's taking ages to load. Right, okay. I don't think that's going to work. So what can I do instead? So I can talk more generally about Shiny. So Shiny is this self-contained web framework for building web apps with R. So we only need R to work it. So we install Shiny on our machine and can write Shiny apps, and they work on our local machine. And then, of course, we want to be able to share these Shiny apps. So these researchers at Oxford aren't just making people download R and run Shiny on a machine. So shinyapps.io is a freemium service for hosting Shiny apps. So the University of Oxford pays for 2 shinyapps.io subscriptions at $399 per month. One is the production and one is the test. So we move between test and production. And the reason that we pay that little is because all that's living there is the R code, which is going and pulling our data in from the repository. What's really nice, actually, is shinyapps.io is hosted over in America. So usually that might be a problem because of GDPR. But it's not a problem, because none of the data lives over there. So the data all lives in the repository, which is nicely covered by GDPR. The code's up here, and it's just pulling up the data and displaying it. So that's really nice. We can avoid GDPR. Well, we are GDPR compliant because of that. But if you're building Shiny apps where users are going to be entering data, which is the thing you can really do with Shiny apps, you can't host on shinyapps.io because of GDPR. So that's the freemium service. You can also download the open source Shiny server application, install it on a server, and run Shiny apps from your own architecture, which is really awesome. And if you're moneyed, then you can pay for RStudio's RStudio Connect product, which is really awesome. Okay. So I don't have too much more. So I wanted to talk about reproducibility with R a little bit. So I made you use RStudio projects. And I said RStudio projects help improve the reproducibility of your work. So I'm over in my RStudio project. I'm going to save my script. So I'll call this notes. And of course, with our research, we're going to have data files. So I'm going to create a quick data file and save it into my RStudio project. So I'm going to go to File, New File, and go down to Text File. And I'm going to create myself a little CSV file. Region, value. So the north is going to have a value of 300. The south is going to have a value of 20. The east will have 400, and what's the other cardinal direction? West. West will have 40. Okay. So I'm going to create myself a little CSV file. So it's not a CSV file yet, because CSV files need to have an empty line at the bottom of them. It's now a CSV file. So I'm going to save it, and I'll call it data.csv. So that's my little data file. So that's a pretend one. Obviously, you have your larger data files. You've imported them into the directory. And then in our code, we can write read_CSV. I type a quotation here. And if you press the tab key, then the tab key shows the file tree relative to where you are. So we can see, oh, why did it not see? Did I not save that file, or did I save it somewhere else? Okay, so if I do... Oh, okay, so that wants to be in my desktop, in here, data.csv. There you go. So now in my code, if press tab, and I can see my little file there. And then I hit Control Enter, and that's going to read in our data file. And this now is fully reproducible, transportable code. So what I need to do now to share this code with somebody is I zip my folder up, I email it to them, they open this file called, with the extension .rproj, it opens up the RStudio project, and this code will work. This code will work because RStudio projects set a relative file path. So all file paths are relative to where the rproj file is. So it makes this code really transportable, really reproducible. So if I turn this into a Git repository and pushed it up to GitHub, people could just clone this and the code will work. You won't have file paths which are Charlie Hadley, OneDrive, Talks, 2022, You've got fully transportable code in here. And that's really awesome. But what about production level reproducibility? So what if you really want reproducibility? You want to ensure that your code is going to work for anyone. You can use the package renv. And what renv does is it saves the versions of the packages that you're using into that project. So whenever anybody opens it in RStudio, they're going to get the versions of the packages that you were using when you wrote the code, which is really awesome. Okay. And then, can I have 5 minutes?
Yes, because you started late.
Yeah? Okay. Oh, I can have maybe 10. Yeah?
Yeah, you're
No. Okay. So, I've talked about a lot of things so far. So I talked about Gplot2 for making static charts. I talked about HTML widgets for making these interactive things. But where are we going to put them? So I kind of told you about Shiny apps, but I wasn't able to show you one because it took a long time to load. And we don't want to build full web applications all the time. Is there a way that we can create a document that contains our interactive things? And yes, we can with R Markdown. So R Markdown allows us to write reports that contain code. So let me tell you about what your life is like without R Markdown when you're using R. You're writing your report in Word, or maybe in LaTeX. You're writing your report, you're writing your code for your charts, you save your charts, you copy and paste it into Word, and you write some more. And then you go, got new data, so I need to go back over to the code, rerun that, copy and paste the chart over to there. And then you go, okay, so in my text of my report, I'm saying that 49% of individuals were A. But then as you collect more data, it's actually 52. And you've got this hanging number here, which isn't connected to your data. So reproducibility is completely broken because you have your data and your code, which is generating all of your statistics. And then you've got your document, your report, with your images, which are disconnected from the data and the code, and your numbers as well are disconnected. So any sentences that contain numbers that are disconnected, reproducibility isn't really there. That's what R Markdown allows you to solve. So R Markdown is a technology that allows you to build reports, presentations, and more that incorporate R code. Here are some of the things that we can build with R Markdown. We can make interactive HTML reports. So if we wanted to, we could build a report with lots of different maps, lots of different charts that people scroll through, and it looks great. We might want to create PDF because we're in academia, and academia runs on PDF, and so R Markdown allows us to generate PDF as well. It also allows you to write fully fledged books. So the R for Data Science book that I mentioned previously, this was all written in R Markdown. So this is a fully featured book. It's got a glossary, it's got an index, it's got a contents page, and all of that stuff is done for you auto-magically by R Markdown. And there's lots of different book-down books that are written with R Markdown. Wrong thing. Sorry. The next thing that you can do with R Markdown, if you really need to, is you can make Word documents. So maybe you're forced to make Word documents, maybe you're in a university where you have to submit exam papers as Word documents, and you go, that's a pain. So you can write R Markdown and generate Word, which is really awesome. And then you might want to do, okay, so I'm really happy making my slides in PowerPoint, but I've got lots of charts. I'd like to just bash them out to a PowerPoint and add my text. R Markdown allows you to do that as well. And finally, R Markdown, oh, sorry, I should say, my slides, they're all written in R Markdown. So these are all R Markdown slides. It also allows you to make entire websites and data blocks. So my consultancy is Visible Data, and my website is built with R Markdown. So this is my website. This is my under-updated blog, and it takes a little while for these images to load, and all of this is written in R Markdown. And this is really awesome for building a portfolio. So if you want to establish yourself as a research software engineer, or something like that, and you want a place to showcase the R code that you're writing and the things that you're building, then writing a data blog with R Markdown is a really awesome way to do that. It's really awesome. Okay, so... And then one more thing. So the really powerful thing about R Markdown is the ability to create parameterized R Markdown reports. So I did some work with a consultancy, R for the rest of us, and we had to generate reports for all 50 states of the US and Puerto Rico. And what we had was we had a bunch of non-technical folks writing all of the reports for each of the states in Word documents, because that's what they were comfortable with. So we had one Google Drive folder with a long Word document with all of the text in for each of the states. We then had Excel files for each of the states as well, and we also had a US census providing us a lovely API that we can pull data from as well. And what we did was we wrote one R Markdown document which was parameterized by state. So we wrote the template, it pulled in the information from the Word document, pulled the information from the Excel and from the US census to build all of these lovely reports. And can I get one of those? I can get one of those. Maybe I can't get one of those. So this report here is for Texas. It's got these lovely maps. It's got lots of text because we wrote lots and lots of text. There's lots of tables in here. All of this was written with R Markdown, which is really awesome. So R Markdown must be really hard to make. Let's go to File, New File, R Markdown. We're going to get this box. This box we can ignore and click OK. And what it gives you is it gives you a template R Markdown document. And what we're going to do with this template R Markdown document is throw most of it in the trash. So let's select everything from line 11 downwards and delete it. Let's write some text. So we're writing our report. So in this study, we did blah, 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 blah. Now we want to read in our data set. So I'm going to insert a code chunk. So I'm going to go to this green button here and insert a code chunk. I'm going to do read_CSV, data.csv. I'm going to save my report. So I've done Command S. And we've got an R Markdown report. And I click on Knit. And I didn't load my packages, did I? So I need to do library, Tidyverse. And when I knit that together, we get our output report. So at the moment, it's horrendous. We couldn't possibly publish this because it's got a bunch of crap in it, right? So it's got library Tidyverse, and it's got all these messages as well, but it's got our data in it as well. R Markdown is really easy to learn. I'm going to point you in the direction of some resources to learn it. yeah, it's amazing. I can make this look a little bit better. So let's go and turn off warnings. Let's load the DT package. Let's pipe it into a data table. Let's hide the code by default. So now I have a much better report. So I've got some text. I can make it bold. And then I've got an interactive table. It's not very interactive, since I've only got one row in it, but you get the concept that with R Markdown, it's fairly easy to combine these things together. And I was trying to tell you about this workflow you have at the moment, where you've got a Word document and you've got your R code, and there's a disconnect between them. There's no longer a disconnect. Your code is inside your document, which is really awesome. And it's really reproducible, because we can compress this, email it to anybody, and they can rerun the report as well. It's the gold standard of reproducibility, because this can easily be put inside of a Git repo, sent it to GitHub or GitLab, and you can pull it. And you can deposit it somewhere that will give you a DOI, and then you've got your tick, and you've actually done reproducibility. So I think that's everything I was going to say about our Markdown. Yeah, okay. So I want to finish by talking about where to go to learn R. So the first place I would recommend is the R for Data Science book. It is really awesome. It really takes you through the process of using the Tidyverse for data wrangling, cleaning, modeling, and visualization. It's really awesome. And the online learning community is a Slack group which will support you and give you help. And it's completely free. Also, the RStats community on Twitter is so awesome and just so vibrant. It's a really awesome place to be and to share things that you do as well. Actually, so while I'm talking about Twitter, so we have this thing in the R community called Tidy Tuesday. So Tidy Tuesday every week comes up with a data set which is public and makes it available through the Tidy Tuesday package. And what folks do under the Tidy Tuesday hashtag is they share the data visualizations that they make. So if you're finding it really hard to motivate yourself to learn R, which I can really understand, particularly if you're doing some really complicated analysis and you go, I can't do all of that in R, but I want to make something, Tidy Tuesday is really lovely, because every week you get a different data set, which is maybe looking at political issues, social issues, or it's looking at the script of All Friends episodes. And actually, there's some really nice visualizations of that data set, which show that Joey doesn't say, what's it?
How you do it.
That's the one. I always say, how am I doing? Which is not right. So he doesn't say it that often. And there's some really lovely visualizations showing that from Tidy Tuesday. So Tidy Tuesday is really awesome and might be a useful resource for the challenges for later.
It is one of our challenges.
Yeah. So hopefully that's useful instead of annoying.
No, definitely useful.
So the next thing is something that costs money. So I co-instruct R in 3 months, twice a year, and it's my favorite thing that I do. It's amazing. So we usually get about 50 people in each intake, and there's asynchronous and synchronous content. So there's videos for each week, which you go through and you learn concepts. And then we want you to use R Markdown to explore your data sets. So we're not saying, use this data set which everything has been done with. Use your data set, wrangle it, make some visualizations, explore it, and each week you submit assignments to me, and I record videos. And those videos can be like 10, 20 minutes long, because I maybe get overexcited about some things, and you get lots of feedback each week, and it's about you solving your problems instead of generic problems. So I really love R in 3 months. It's really awesome. It is $999, so it's not for everybody. But that's because it's co-instructed and David decides the price. But it's a thing that exists. I really enjoy doing it. It's great. And then LinkedIn Learning is a service that provides training courses. And I have produced 5 different courses for LinkedIn Learning, including a course on Shiny. So if you want to learn Shiny, I highly recommend my course on Shiny on LinkedIn, because it's designed for folks who are focused on data. Most of the documentation you find on Shiny is really programmer focused. So my course in that, I really like it. I made it. It's focused on doing data things. There's also a 5.5-hour course on HTML widgets. So 5 different HTML widgets and how to use them. And there's also training on how to use R markdown as well. Many universities provide access to LinkedIn Learning to all staff and students. So Google the name of your university and LinkedIn Learning, and you might already have access to it. Or you can sign up for a free trial to LinkedIn Learning, and sign up for a free trial for LinkedIn Premium, and you get LinkedIn Learning with that. And don't worry, I also get money if you're using a free trial and watching it. It's all fine. It's all great. And I did finish at 1:30.
You did. Thank you very much.